Good day, ladies and gents. We're in our next video to study for the end of course exam. So we're going to be focusing on worksheets 3 and 4. And if we have time, we'll do 2 and 5 on top of that. All right, let's get going. All right, so make sure you guys have out your hot topics because we're going to be doing Unit 2. So make sure you have that. So it's Unit 2, and also it's the top half of this worksheet right here of that hot topics. All right, let's get going. All right. So we're going to start on worksheet number 3. All right. So fill the chart. So this is how do we get from so taking a slope and going to parallel. So if you look at your hot topics, so for parallel, you have the same slope. So if you have a positive 3 or 4, it stays that way. And if you have a 4, it's still technically a 4. So parallel stays the same. Now for perpendicular, you flip the sign and flip the fraction. So here are a bunch of examples. So this is a positive 3 over 4, so it turns into a negative 4 over 3. And same thing here. 4 is really a positive 4 over 1, so it would turn into negative 1 over 4 for perpendicular. All right, so let's do a couple examples here. So parallel would just stay exactly the same. So you would have to do 1 over 2. If you put positive 1 over 2, it's going to be wrong. Just pointing that out. Okay, so perpendicular, we have a positive 2 over 3. So what would that turn into? That would turn into a negative 3 over 2. You flip the sign and you flip the fraction. So negative 3 over 2. And I'm going to just do one more example for you. All right, so right here, we have a positive 3 over 1. So for parallel, it stays exactly the same. So you would just give me the number 3. Now, if you give me a positive 3 over 1, it will be wrong. If you give me a positive 3, it will be wrong. If you give me 3 over 1, it will also be wrong. So you have to make sure that you clean these up as much as possible, and that is as clean as it gets. All right, sweet. All right, let's go on to number 2, and it's your job to finish those two examples. For number 2, a line has this equation. They want the perpendicular that goes to this point. All right, so here are the basic steps. For equation of a line, first of all, find the slope. So if you're given a graph, if you're given an equation, so basically you need to, if you're given an equation, you need to pick out the slope you have. Then if it says parallel perpendicular, you give me the same slope for parallel, you give me the perpendicular slope for perpendicular. You flip the sign and flip the fraction. And we had those examples right there earlier, right here. Okay, so step 1 is find the slope. Step 2 is find the y-intercept. So you plug everything else in, solve for b, and then step 3, you just write the equation nice and clean. So make it pretty. All right, so in this case, so they said they want the perpendicular of this, right? Okay, so if we have y equals x plus 4, so that's what we were given. So there's an invisible 1 right here. Sorry, let me fix this a little bit. So there's an invisible 1 right here. So our slope at this moment is 1. So if we want the perpendicular slope, so that's really just a positive 1 over 1. Okay, so the perpendicular slope, you flip the sign, which would be a negative, flip the fraction, which would still be 1 over 1, and now clean it up, and that would just be negative 1. So now that you have that, this sucker disappears. We don't care about that anymore. So we have m equals negative 1. That's the first step. So find the slope. Okay, second step is to find the y-intercept. So to find the y-intercept, okay, so we're going to start with our equation, y equals mx plus b. We're going to plug in everything else and solve for b. So we're plugging in y, m, and x, right? All right, so this is my m right here, and then this right here would be my xy. All right, so plug those things in. So we have my y is 3. A lot of people accidentally put 2, so be careful, equals negative 1 times your x, which was 2, and then plus b. All right, so 3 equals, that would be negative 1 times 2 is negative 2 plus b. Add 2 to both sides, and you get 5 equals b. All right, so that was step 2. So step 1 was find your slope, step 2 was find your y-intercept, and step 3 is just write out the equation, right? Plug in your slope and your y-intercept. So the equation. Okay, so y equals mx plus b, where you're plugging in just your m and just your b. So y equals negative 1x, and then plus that 5. All right, now clean it up. I can't leave it like this. Y equals negative 1 times x is just negative x, and we get plus 5. That's your final equation. Y equals negative x plus 5, and that's as pretty as it gets. All right. Number 3, same steps. So step 1 is to find your slope. All right, so what do we have so far? So they have this equation right here, and they want the parallel slope of that, right? So they want the parallel slope. So y equals negative 0.25x plus 5. So y equals negative. So what's a better way of saying negative 0.25? That's the same thing as saying 1/4. So it's negative 1/4 x plus 5. All right, so our slope at this moment is negative 1/4. So we want the parallel slope. So that would still be negative 1/4. So that is our slope. M equals negative 1/4. That's our first step. So then this sucker disappears. I don't care about that plus 5. The only thing I wanted from here was the slope. All right, step number 2 is the y-intercept. So y equals mx plus b. You plug in everything else. So this is my x and my y. Plug in everything else and solve for b. So we're going to plug in all these things and solve for b. So y is 4 equals your m, which was negative 1/4, your x, which was 8, and then plus b. All right, just put this over 1 and multiply straight across. So that's 4 equals negative 1 times 8 is negative 8, and 4 times 1 is 4, plus b. So 4 equals negative 2 plus b. You would add 2 to both sides, and you get 6 equals b. All right, and your final step is write out the equation. So y equals mx plus b, where you plug in your m and your b, and I'll leave that part for you. So number 3, I got you all the way there. You just need to finish it off. All right, number 4. All right, number 4, we have this. We have this equation right here. And they said that they want the perpendicular, and it passes through this. So now multiple choice, you can use that to your advantage. We know it goes to this point. So you can go through all the motions, or, I mean, there's a bunch of different ways. We know for a fact that it has to go through this, right? So a couple different ways how to do this. One is take your, when you plug in x is 3, y needs to pop out with 3. So if so one thing I can do is I know for a fact it goes to that point. So what I can do is this equation, 8 divided by 3 times, and I'm plugging in 3 for x, times 3, and minus 5. If I pop out with a 3, then this is still a possibility. So this is a possibility. It doesn't mean that's the right answer, though. So it's a possibility. So how about this other one? So parentheses, negative 3 divided by 8 times 3, add 8. Do I pop out with a 3? Okay, so this one is definitely out. There's no way that this one works. So this equation is totally out. All right, how about this one? So I'm going to see if my left side is equal to my right side. So if I plug in 3 into here and 3 into here, what would happen? Because they said they just happen to be the same numbers, okay? So if you plug in 3 for x and I plug 3 in for y, does the left side equal the right side? So 15 plus 3 times 3, I get 24. The question is, does that equal the other side? 8 times 3. Yeah, so this is still a possibility. So that's still possible. It doesn't mean it's the right answer, but it's a possibility. And on this other one, 16 plus 3 times 3, I get 25. Does that equal 5 times 3? Nope, that's totally gone. So just using this point, I know for a fact that this is gone and this is gone, and so these two are the possibilities. At the very least, you've narrowed it down to 50-50, 2 choices, right? On top of that, they said perpendicular. So I have negative 3 over 8, so the perpendicular slope would be positive 3 over 8. Is that what we have here? No, so there's no way that works because of that, right? So there's, so they said perpendicular, so it has to be positive 3 over, so So negative, oh shoot, I'm a dork. I forgot to actually flip it. So positive 8/3. So yeah, so that is a possibility. Jeez, I'm so silly. All right, so that is still a possibility. So that's still a possibility for the slope. So for the point, it worked. For the slope, it still worked. And this one, I don't even know. I have to actually solve for this. So I'm only going to waste my time with this one. So 15 plus 3y equals 8/8x. Solve for y. Subtract 15 from both sides. We get 3y equals 8x minus 15. Take each one and divide by 3. So y equals 8/3 x minus 5. Okay, so we know that it goes to that point. So it is 8/3. That checked out, and does it go through 3, 3? Yeah, we checked that earlier. So the slope is still good. So so far it's only those two right there. Now, what are some other ways we could have done this? Another way that we could have done it is take each equation, make sure that we solve for y. So A, B, and C, and D, right? So just recapping. So one way is check, hey, if you plug in X and Y in, did they check out? Yep. And the other way is actually to solve for stuff. So so for like A and C, we figured out if the slope worked. We figured out if the equations worked, stuff like that. So anyway, so that was just a couple of different ways how to do this. Sorry for the typo earlier. All right, so the basic gist, make sure you have, you see if the points work. So boom and boom, and then you see if the slopes work. So that was basically the two steps, and both of them were good to go. All right, number 5. Number 5, find each equation. So find each equation, and we have, so this is still correct, y equals 3/5x minus 3. Okay, in this other equation, in order to get y by itself, we're going to divide each thing by 5, right? So we get y equals 3/5x minus 2. Now, how do we know if it's parallel, perpendicular, or neither? Okay, so we look at the slopes. So are they the same? Or did they flip the sign and the fraction? Because it had to do both of them. Or did it do neither of those? So we have the exact same slope, so that would be parallel. Okay, and finally number 6. All right, if the two lines are perpendicular, so it's perpendicular, what do we know about the slopes? Okay, so looking at our hot topics, don't reinvent the wheel. All right, it says it right here. So, so the two choices here. So if I said that they were parallel, the slope would be the same, but the y-intercept would be different. Versus if they were perpendicular. For perpendicular, your slope would be the negative reciprocal, and the y-intercept could be anything. Okay, so which one did we want? We want perpendicular, so there's the answer. All right, awesome. Moving on. All right, so let's go to page number 4. So we're on page number 4 now. So page number 4. Page number 4. All right, so we're looking at our hot topics. So hot topics, they're awesome. Okay, so we know vertical, those suckers are equal. Supplementary, which is super important. A straight line creates 180 degrees, makes a rainbow of a straight line, right? Okay, and there's a bunch of other words. We also know that you can copy paste. So angle 1 be equal to angle 5 because of corresponding, and you have all these other rules that you had to memorize. But it basically makes good sense. Okay, so 4 and 7. So 4 and 7. So what you want to do, I'm going to fold this to help me out here. So I can turn this a little bit. All right, so here's 4 and 7. So you want the train to go vertical. All right, so the train tracks always go vertical, and then I'm going to cover up the rest of this so I can just focus. So here's 4 and 7. So the train tracks are always vertical to you. Now 4 and 7, are they on the same side or alternate sides? So they're on the same side, right? So because they're on the same side, that narrowed it down to either corresponding or same side, whatever. So these are on the same side. Now, did you copy paste? So you see how 7's in the bottom left corner is 4 in the bottom left corner? So that means it's not corresponding. So it's not corresponding. So then they're both inside the triangle. Sorry, in triangle. They're inside the parallel lines. So that's same side interior angles. So remember, all those are interior. So 12 and 15 would be another example of same side interior. All right, so 4 and 7 is same side interior. And you just have to keep going through all those rules. So here are examples, what the angles would be, so stuff like that. So basically ask yourself, are they on the same side or alternate sides of the train tracks? Are they interior angles or exterior angles? And then you can, or is it corresponding, meaning it's a copy paste? So we've done a bunch of examples of those. If you just need a refresher, make sure you check back on previous videos. I'll just do one more. How about number 7, 7 and 10? 7 and 10. Now, 7 and 10. Is there a train that goes from 7 to 10? If there's not even a train that goes straight from 7 to 10, then that would be none. So just putting that out there. 6 and 7. Okay, I'll keep picking bad examples here. 8 and 13. Okay, here's 8 and 13. So the train that goes from 8 to 13 is right here, so it's already vertical to you. So 8 and 13, are they interior, exterior angles? They're both interior angles. So, and then are they on the same side or alternate sides? They're on alternate sides. So alternate interior angles, and that's the answer. So are they same side or alternate sides? Are they interior, exterior? Or is it just a straight up copy paste job, right? So if there's no train, then it's just neither. All right, so then we have, so that was for 13, 18. So 13 and 8, so right here. 8 and 13, we had same side interior angles. All right, so just putting it out there. It's your job to finish those. Okay, number 2. Okay, if the lines are parallel, form supplementary angles. So supplementary angles, now here's the thing. Supplementary angles are basically any angle that adds up to 180 degrees. So we're used to seeing this, where, but supplementary could be any angle that adds up to 180 degrees. All right, so here we go. So let's say, so let's just do an example. So, so we're just making it a random example. So if this was 80 degrees, what would this be? 100, and this would be 80, and this would be 100, and then you would just copy paste, right? So 80, 100, 80, and 100. So we just made something up, and now this would be true. If this one thing was 80, then all these would be true. All right, so do these add up to 180 degrees? So 8 is 100, and 6 is 100. That made 200, so that's a no-go. And then you would just keep going, like which ones work. So which ones add up to 180 degrees? And you would just keep finishing that off. All right, number 3. All right, so on number 3, okay, so you see what it looks like? So this is kind of hard to tell where stuff's located. And is it acute or obtuse? Because that was another way of seeing it. So obtuse and acute, if they're different, then they add up to 180 degrees. If they're the same, they equal each other. If they're both obtuse, they're equal. If they're both acute, they're equal. If one's obtuse and the other one's acute, they add up to 180, which is basic just as what we were saying earlier. So what you could do is you could exaggerate the picture. So here's me just exaggerating this picture just more, and it's much easier to tell if it's acute or obtuse. All right, so we have TSU. So it's at S. The question is it which one of these 4 is it at? So TSU, so that's down here, right? So that is 8x minus 14. Okay, I'm going to make that blue. 8x minus 14. And at W, so VWX, so this right here, is 5x plus 34. Now, is it acute or obtuse? And if you're having trouble figuring it out, use the corner of your paper. All right, so this one is bigger than 90 degrees, so that's obtuse. And this one is also bigger than 90 degrees, so that's obtuse. They're both obtuse, so that means that they are equal to each other. So 8x minus 14 is equal to 5x plus 34. Okay, and solve. So I'm going to subtract 5x from both sides. We get 3x minus 14 is equal to 34. Add 14 to both sides. You get 3x is equal to 48. We're going to divide by 3. I'm just showing more work than I need. Okay, and we get x is equal to, so 48 divided by 3, and we get 16. All right, so we have x is 16, right? Now we take that and we plug it in. So we're going to, now that we have x, plug it back into the picture, right? So plug it back into the picture. I'm doing 8 times 16 minus 14. So 8 times 16 minus 14, and this would be 114. And I do it to this one as well. 5 times 16 plus 34. So 5 times 16 plus 34, we pop out with 114. And they were supposed to be equal, so that's great. Now, once you have this one angle, you can actually find all the angles, right? So we have that this is 114 and this is 114. I'm just putting it back over here. All right, so now you can find every angle, right? If this is 114, and these have to make 180 degrees, so this have to be 66. This would be 114. And be careful with the double digits. A lot of people do 144 by accident, and this is 66, right? And same thing over here. If this is 114, this would be 66. This would be 114, and this would be 66. All right, and now answer their questions. So be careful. A lot of people would have stopped at X, but they wanted these angles. So they said Y. So we're at W, right? And we said Y, W, X. So that's this angle right here. So that's 66. So they wanted this angle down here. Tricky, tricky, tricky. And then they said angle S. So right here, so it's one of these four. R, S, W. So RSW, that's right here. And that's 114. Excellent. All right, number 4. So draw 2 lines in a transversal such that angle 3 and 4 are alternate interior angles, and 2 and 3 are vertical. All right, so alternate interior, so that means 3 and 4, they're both on the inside of the 2 lines. So it could look like this, or look like this, or look like this, like that, stuff like that right there. And then 2 and 3 have to be verticals from each other. So it could look like this, or look like this, or look like this. All right, so let's start off with the easier one. 2 and 3 have to be vertical, right? So here's 2 and 3. Yep, that checks out so far. So 2 and 3. Nope, that doesn't work. So those are not vertical. Okay, 2 and 3. Yep. 2 and 3. Nope. All right, so far I narrowed it down. And then and then 3 and 4 have to be alternate interior angles from each other. So here's a train that goes from 3 to 4. Are they on the same side or alternate sides? 3 and 4 are on the same side here, so that's no good. So here's a train that goes from 3 to 4. Are they on alternate sides? Yep. Exterior. Gosh darn it. Exterior angles. It's supposed to be like this. Man, hate when I make typos. So 3 and 4, they're exterior angles. Gosh darn it. Okay, so 3 and 4, exterior. So that was the answer for that one. Okay, so that was 4. All right, we still have time. Let's go ahead and go to page 2. Let's go to page 2. So we're on page 2 here. Please forgive me for the couple of typos I have so far. Okay, so if DE bisects. All right, what does bisect mean? That means it cuts it in half. So it cut. So what got cut? This got cut. So angle B, so ABC. So here's ABC, from ABC right here. That got cut in half. DE is the thing that cut it in half. So this angle right here got cut in half, so that means that this angle is equal to this angle. That's what that means. Bisect means it got cut in half. If you don't remember that, then make sure you make a note about that on your Hot Topics page. All right, so we got that, and they said that ABC, so that's a whole shebang here, is 7x plus 29. They also said that DBC, so DBC, so this angle right here is 99. So this angle right here, DBC, is 99. All right, and what do they want? They want x. All right, so do you see this straight line right here? We know that that makes 180 degrees, right? So if all this from here to here makes 180 degrees, I know that that angle right there, 99 plus that CBE, so that angle right there adds up to 180 degrees, right? So 180 minus 99, that angle CBE, is equal to 81. Now, this is a bubble thought. You don't need to write that down, but I know that this would be 81 degrees. So if this is 81, what does this have to be? This have to be 81 because they're both equal. So what would the whole shebang be? 81 plus 81, all of that would add up to 162. So this angle is 7x plus 29. This angle is also equal to 162. So if they're both the same thing, then they are equal to each other. So we're going to set 7x plus 29 is equal to 162. All right. So then set those two equal. So solve for x. Subtract 29, and you're going to get x. And that's all they asked for. So that's your job to finish that off. Okay. Number 2. All right, number 2. Oh, I love this one. This is great. It's just label like crazy. Just label like crazy, see what happens. All right, let's see here. Just start with random stuff. All right, do you see how there's 90 degrees here? So if this is 90 degrees, I know that so 90 minus that 63, this would have to be 27 to finish the 90 degrees off right there. All right, let's see. What else? A triangle altogether adds up to 180. So I know that all three of these add up to 180. So 180, show my thought process here. All right, so 180 minus 88 and minus that 27. So this would have to be 65. All right, let's see. What else can we do? Let's see. Just starting with random spots here. Okay, so this right here is 90 degrees, right? Let's see. What else we got? We have, there's a straight line. All right, so we have this straight line right here, right? So this straight line makes 180 degrees. So 180, subtract that 88, and we're stuck with 92. Oh, and there's a triangle. So this triangle makes 180 degrees, right? So if we have 180 degrees, we're subtracting the 92 and the 63, we would have 25. Let's see, what else can we find? Okay, straight line, that doesn't work. We don't have these angles. I don't know this. Let's see, did they give us anything else? Right here, they said that these lines were parallel. That's really important. So if those lines are parallel, so they said KR is parallel to here. Now, our best friend for that is Z's, right? So if we turn this, for parallel lines, your best friend are alternate interior angles. So this right here, so this corner, alternate interior angles, this angle equals this angle. So if this is 63, this would also be 63. That's really important. Okay, so just starting, and there's a bunch of different ways how you can do that, but that's the easiest one so far because that's our best friend. All right, and now we can make this straight line. So we know that all of this makes a rainbow of a straight line, right? So 180, we're going to subtract the 63 and the 25, and we're left with 92. Okay, now we have all three of these angles are supposed to make 180 degrees because they make a triangle. So 180, subtract the 45 and the 92, we're left with 43. Okay, Let's see what else we got. And here's another triangle, right? So that triangle makes 180 degrees. So 180, we're going to subtract the 63, and we're going to subtract the 90, and we're left with 27. All right, so we found all the angles, and all you have to do now is plug all those angles in and type them all in there. So hopefully you like that one. All right, let's see what else we got. So we have ABC here. So we know all this makes up 90 degrees, right? So basically, I know, so straightforward, I know that that angle 1 plus y is equal to 90 degrees, right? Okay, but they want you to solve for angle 1. So how do you get angle 1 by itself? You would subtract y from both sides, right? And that's it. 90 minus y is equal to angle 1. Okay, over here, number 4. So it's the same idea as before, just finding straight lines and stuff like that. Let's see. I know this is 59, right? And then you see this right here. Those are vertical angles. So if this is 59, this is 59. Okay, and then I know this makes a straight line, but that's a y and an x in here. So all three of these add up to 180, but that doesn't help. How about this? Okay, that's an x, a y, and a 59. Nope, that's too much. This one's the best one. So we have 7y minus 4 plus 59 plus 3y minus 5 is equal to 180 degrees. And now all you have to solve is solve for y. When they're on the same side, do the same operator. 7 and a 3 make 10y. Negative 4, a positive 59, and a negative 5 make it 50 equals 180. And you just need to keep solving. Now, once you solve for that, you plug it back into the picture. So plug it back into the picture, and then you'll be able to solve for x. Because remember, once again, these have to add up to 180. So you'll have this number. You know what? Let's just solve it. So 10y is equal to 130. Y is equal to 13. All right, so you found that. Plug it back in, right? So 3 times 13 minus 5, this would be 34. 7 times 13 minus 4, we get 87. All right. And then what would this angle be right here? If all those add up to 180 degrees, 180, subtract the 34 and the 59, this angle would have to be 87. This angle is 87. This angle is also 12x plus 3. If they're the same angle, then they are equal to each other, and now it's just your job to solve. Okay, and then you just rinse and repeat for these things right down here. So, and remember, you have your hot topics page. Like there's examples on here. Okay, and let's keep going. So we got that one down. Okay, so we got page 2, 3, and 4, and let's go to 5. All right, so we're on our last page here. So going a little longer than I was expecting for each day, but that's okay. All right, so constructions. All right, so here are the basic rules right here. So these are things to memorize, but you can actually just fake it till you make it, right? All right, so list the steps on how to do the construction, and don't reinvent the wheel. There's multiple choice here. Okay, so without moving the compass. Okay, now we cannot without move the compass if we haven't placed the compass anywhere. So that we can't do that. Draw a ray from a draw a ray from A through the intersection of two arcs. Huh. Now how am I supposed to do that if I don't even I don't have anything? Let's see. Put the point of the compass at A and make an arc. Okay, so that's actually so we're doing something. That's doing something first. So that sounds very promising right there. All right, so so that's going to be the first thing. So that's B. So we put our compass somewhere, and then we made a point. So put your point on the compass A, at point A, and draw an arc through the two sides. So basically, I'm just like that, right? That's the first step. Okay, then without moving the compass, place the point on point B and draw between AB and AC. Okay, so that sounds promising. So that would be A, and then draw a line. Yeah. So this is me just faking it. So you would go here, and then go here. So we're going from these points, and then there's your bisector right there. All right, and if all else fails, you can sit here and memorize these things. So they said angle bisector. So here's the angle bisector, and those are steps. If you just zoom in, place, do it, and then draw a ray, right? Okay. All right. So sweet. And then you just keep faking it. You're like, here are the steps, and you try to put them in order to make sure that they made sense. So just keep faking it. You can't make like using a straight edge, draw X, Y, label the intersection. So using a straight edge, draw X, Y. Now you can't draw X, Y if you don't have X and you don't have Y, right? So like, what's your point of this? Is to draw this line through these intersections. You can't draw that line unless you have those points. So just looking at this, I know that this right here would be my last step. That would be my last step. I can't, this is, the whole point is to draw this line, so that'd be my last step. Keeping the compass at the radius, well, I can't keep the compass here if I don't have it already set. Place the compass at A. See, that makes more sense. So it's CAB. So you can just put these in order by just faking it, right? Okay. I'll leave you guys for 3. And 5. You guys can figure that out on your own. Okay, and then on this one, if you look at your hot topics, this octagon, let's see. Just looking for examples. All right, so for this one, okay, so that would be, how many points do we have here? We have 24 points. You just sit there and count them all, right? And it's going to be a regular octagon. So that means you're going to divide by 8. So, because there's an octagon, right? Okay, so that means every 3 dots you're going to put something there. So, and now let's draw it. Okay, so starting here, go 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And if you start at a different point, it doesn't hurt anything. And then 1, 2, 3, we land it again. Okay, and then we draw straight lines between those points. And there you go. Yeah, 8 sides. And we're done. And hopefully that helped you guys out. Have a great and wonderful day.